Hi everyone. So in lecture 7, we're going to be learning about mass number, atomic mass, and its relation to valence electrons and group number. Alright, so let's go ahead and read number 1. Mass number versus atomic mass. To identify which element an atom is, we look at how many. No element is going to have the same protons, so the number of protons is going to be unique. Atoms of the same element but differ in number of neutrons are called isotopes. Alright, because they are different in the number of neutrons, they will have different masses. An atom of 1H weighs about 1.0 AMU, and an atom of 2H weighs, so that's going to add 1 neutron, which will give us about 2.0 AMU, an atomic mass unit, and an atom of 3H weighs, so you add another one, which is about 3.0 AMU. In nature, 99% of hydrogen atoms are 1H, so most of them only have 1 neutron and 1 proton. So what do you think the weighted average mass of hydrogen atoms will be? Look up the atomic mass of H. Does that match? So, for hydrogen to have 1 neutron and 1 proton, it'd be about 1 AMU, and it'd match with the atomic mass, which is 1.00794. And number 2, electron dorming. So we just learned that electrons of an atom live in different energy levels, radiating away from the nucleus, starting with level 1, then 2, then 3, then 4, etc. These energy levels are quantized, meaning discrete levels, so no electrons can be at level 1.5, for example. Level 1 can house 2 electrons, while other levels can house up to 8 electrons, so only 2 electrons fit in level 1. So no more than 2, not 3, not 4, but 2. And then level 2 will have 8. So for example, neutral sodium has a total of 11 electrons. If you put them in their energy levels, you first put 2 in level 1, then 8 in level 2, then the last one in level 3, and all of those equal to 11. So 2, 8, 1 equals to 11 protons, which is the element sodium. Alright, so we're going to look at lithium. Now lithium has number 3 as its atomic number, so it's going to have 2 in the first level, always 2, and then it has 1 more to add up to 3, which is going to be 2, 1. Carbon has 6, so it's going to be 2 in the first energy level, 4 more to go, so it can definitely fit into the second one because it has a maximum of 8, so it's going to be 2, 4. And then helium has 2 protons, so it fills up the first electron level. And for beryllium, 4 protons in the nucleus, so it's going to have 2 plus 2 equals 4. And sulfur, 16. So even though it's a bigger number, we're going to split it into its electron levels. So 16, so we got 2 in the first one, plus 8, which is the maximum for the second electron level, which makes it 10. So we need 6 more, which can fit into the level 3. Alright, so for fluorine right here has 9 protons. So we got 2 in the first electron level, 7, so 7 right here equals 9. So it's going to be 2, 7. Alright, number 3. It's what's on the outside that counts. Electrons that reside on the outermost energy level of the atom are called valence electrons. So they're going to be on the last energy level of the element. And the number of valence electrons of an atom dictates what family it belongs to and plays an important role in its chemical reactivity, as we shall learn in later chapters. Identify the elements that have the following electron level arrangements. Then indicate how many valence electrons in each element along with the group number. Alright, so regarding the group number, it's going to be from here to here. So we're going to count off 1, 2, 3, 4, 5, 6, 7, and group number 8. So the relationship between valence electrons and the group number is that they're literally the same number. So if an element has 3 valence electrons, it'll be in group number 3. So for A, it's going to have 2 in the first energy level and 3 in the second. So it's going to add up to 5. which is 5 protons in the nucleus. So which has 5? It's boron, which we talked about. So we're going to put boron here. And the number of valence electrons is going to be the outermost, which has 3. And again, it's going to correlate with the group number because it's going to be the same number, which is 3. All right, so we got for B, 281, which equals 11. Let's go ahead and write the element. The number of valence electrons is 1 because it's in the outermost energy level, and it's also going to be in group number 1 because it's the same number as the valence electrons. So for C, you got 2 and then 2, which equals 4, which has 4 protons. It's going to be beryllium, 2 valence electrons on beryllium, and the group number is 2. All right. And then for D, we got 288. So 2 plus 8 is 10, and then plus 8 is 18. So the element with 18 protons is going to be argon. All right. And argon fulfills the third energy level, which is 8. And it's in the group number 8. All right. So for E, we got 287. So we got 2 plus 8, 10, plus 7 is 17. Element chlorine, which has 17 protons. And it's going to have 7 valence electrons in the outer energy level, and it's going to be in group number 7. Next page. Again, valence electrons are super important. Let's make sure we know how to count them. So how many valence electrons does an element in group number 5A have? All right, so group number 5A, which is this one right here, we got nitrogen, phosphorus, and arsenic. What they all have in common is that they're going to have the same number of valence electrons because they're in the same group. So it's going to have 5 valence electrons. All right, so for B, how many valence electrons does an element in group 6A have? Since they are all in group 6, they're going to have 6 valence electrons. How many valence electrons does carbon have? All right, so if you go to carbon, you can see it's in group number 4. So it's going to have 4 valence electrons. And then for D, how many valence electrons does sodium have? Let's go ahead and go to sodium. It has 11 protons, and it's in group number 1. So it's going to have 1 valence electron because it fulfills the first 2 energy levels, 2 and then 8 in the second one, and in the third one it has 1. And for E, how many valence electrons does fluorine have? So fluorine is group number 7, so it's going to have 7 valence electrons. Number 5, line them up, part 1. How far away the electrons are to the nucleus dictates the size of the atom. So in other words, the higher up it is in the periodic table, the closer the electrons are to the nucleus. And the farther down, the farther the electrons are from the nucleus. Arrange each set of elements in order of increasing size based on periodic trends. Use the less than sign and summarize what the trend is going across the periodic table and going down the periodic table. So these are going to be smaller atoms, and because they are expanding, these are going to be bigger atoms. So we got silicon as the least, and it's less than phosphorus, and then phosphorus is less than sulfur. All right, for B, we got SN, Si, and carbon. So because carbon is on top here, it's going to be a smaller atom. So we're going to put C first, is less than, we got silicon in the second period. And then tin is all the way in period 4, so it's going to be larger. I'm going to put that in the end. And Mg, Ca, and Sr. Magnesium is less than calcium, which is less than strontium. All right. And then we got fluorine, chlorine, and bromine. And they're all in order. All right. So fluorine is on top of chlorine, so it's less than chlorine. And chlorine is above bromine, which is going to be right here. All right, so line them up, part 2. How much attraction between the electrons in the positive nucleus dictate the ionization energy of the atom? So arrange each set of elements in order of increasing ionization energy based on the periodic trends. So from this side of the periodic table to that side, it increases. So ionization energy levels increase this way, and going down the periods, it will decrease, and as you go across, it will increase. All right, so let's look at A. We got O, N, and F. All right, so oxygen is going to be all the way here, and then we got N behind O, we got F at the end. So we're going to write those in order, N, O, F. And these are arranged from least to greatest in ionization energy. And we got aluminum, chlorine, and sodium. Sodium is first, and then aluminum is in the middle, semi-middle, and then after that it's chlorine. So we're going to write aluminum and then chlorine. And then for lithium, sodium, and potassium. From bottom to top, we got potassium, which is less than sodium, which is less than lithium. All right, so we got in D, potassium, we got calcium, and we got bromine or bromine. Potassium is in the beginning of the periodic table, and right next to it is calcium. And all the way in the very end is bromine. All right, and that concludes lecture number 7, practice problems.